So in today's lesson, we're going to be talking about evaluating expressions. And all that's asking is evaluate means solve, and an expression is an algebraic situation without an equal sign. Now you may be like, but there's an equal sign right there. The expression over here is x plus 3. Okay, so essentially it's not saying like x plus 3 equals 4 or anything like that. It's just saying x plus 3. And in order to solve this expression right here, it says x plus 3, and then there's a little semicolon. It's just saying take a deep breath, and it says x equals 9. So if it's x plus 3 and x is 9, what I'm going to do is take this, and I'm going to, we call it substitute or plug it in for x over here. All right. Well, if x is 9, that means this is 9 plus 3. And 9 plus 3, that equals 12. Now, you may notice that I plugged it in the x, the 9, directly underneath each other, the pluses and the 3's directly underneath each other. Very, very important. All right. Algebra is a lot of organization, and especially at 6th grade, organization can be a mess. So we're all about organizing our papers. It must go directly underneath everything else. Is nice and organized. And then I don't have, this is something I see common mistaken, is students will go equals 12 to the side. And then it gets kind of messy. We're looking for almost that upside down, kind of like in order of operations, that upside down triangle right there. All right, we're working from more complicated down to the least complicated. And like I said, 9 plus 3 was 12. Next problem. So that was addition. You would do the exact same thing for subtraction. Next, we're going to look at multiplication here. And this says 2b. All right. What's hidden here, and we do not have to write it in algebra, is a multiplication sign. This is actually 2 times b. All right. Big misconception. Students will be like, oh, well, b's 7, so it's 27. They'll just put, like I say, Hulk smash, kind of like, you know, the Hulk. You do not Hulk smash numbers together, okay? This is not a 27. This is an elegant problem, all right? It's 2 times 7 right there, all right? So it ends up being 2 times 7, which is 14. Once again, organization, the 2 was underneath each other. I added in my multiplication sign because if I don't, it's just 27. With a letter, it's assumed it's multiplication. And then we get 14. Another way you can think about it, and I tell myself, I have 2 b's. Well, what is b? It's 7. So I have 2 7's, which gives me 14. All right, just a different way to maybe think about it in that respects. Next, and division would be the same thing. There is always a symbol for division. It's just the typical division sign. You could see it as a fraction as well, because fractions are also division. Finally, we're going to combine the two, and this is where order of operations become key. We have the problem 3m plus 4, m is 2. Okay? Well, 3... And remember, just like from the previous problem, there's no multiplication sign, but it is assumed. This is 3 times m, which is 2, plus 4. All right. Order of operations tells me I have to do, box this in black here. Order of operations tells me I have to do 3 times 2 first, which ends up giving me 6 plus 4, which is 10. And I'm going to box out my answer. So that's evaluating expressions. The biggest thing, we're really working towards that upside down triangle going from most complicated all the way to the least. I'm not looking for any where we go 6 plus 4 equals 10 here. I'm also not trying to skip steps and do multiple steps in one time. Everything is just brought down. I'm showing everything for my work. Like I tell my students, they need to show the work as far as what is 3 times 2 as an answer. I don't expect them to go to 3 times 2 on the side of their paper and do that. But I do expect this is work to be shown.